All right, Algebra students, this is part 2 of 9.4b, and we are completing the square to convert from standard to vertex forms of a quadratic function. Okay, if we're given a quadratic function in standard form, so we have a quadratic function in standard form, okay, we know that what that is, y equals ax squared plus bx plus c, and are asked to find, sorry about the typo there, asked to find the minimum or maximum from it, we can convert the function to vertex form, which is y equals a times the quantity x minus h squared plus k, by completing the square. All right, let's actually do this. So write y is equal to x squared plus 4x minus 1 in vertex form. We're going to do that by completing the square. And I think you're all probably getting good enough now that I can skip a couple steps. Okay, so maybe I can show you two realities. Okay, here's reality. We'll make a little division line here. Here's one reality. One reality, you're going, oh, I know, I already know how to do this. You can do this really quickly. You can just write quantity x, as long as there's a is equal to 1, by the way. A has to be 1. You can just take b, you can divide it by 2. Okay, whoa, there we go. That's 2 quantity squared. And then you're going, wait, I now, that embedded in this is the added 4. I also need to subtract 4. That subtracts the 1. Now I have minus 5. Okay, that's how quickly I can do this. That's kind of reality number 1. Now, reality number 2 is, what did you just do, Mr. Flunkett? I have no idea. Okay, let me slow it down. Let's go over it step by step and see if it makes a little more sense. Okay, so we have x squared plus 4x. Good, we want that. We have a equals 1, right? Now we want to add something to this and subtract it so that we get a perfect square trinomial. And then this minus 1 is just chilling way out here at the end, just like the 40 in the last problem. Okay, what number do we add? We take b, we divide it by 2, which is 2, and we square it, which is 4. So we add 4 and we subtract 4. Now this here, this trinomial is a perfect square trinomial, and therefore we can use our special product pattern. And that special product pattern, I keep on glossing over it, but it's this one, you guys. It's the quantity a plus b squared, right, is equal to a squared plus 2ab plus b squared. And as I always say in math, one of the things is we usually go in one direction. We practice a lot of algebra in one direction from this left to right. We're going the opposite direction. We're going from this, right, this product, which is a trinomial, and going back to its factors. And so this is a squared, so a must have been x. This is b squared, so b must have been 2. And then it's plus plus, so that's a plus in between, not a minus. And then squared, and then we can do 2 times x times 2. Yep, that's 4x. It all worked. Minus 4 minus 1 is minus 5. And as you can see, this is precisely what I got the first time through. Why do we do that? Look how easy. It's not that hard. Once you know how to complete the square, it can be a very, very fast way to find the vertex. This is at hk, so the vertex is at -2 and then -5. A is equal to 1, which is, I'm going to use this, greater than 0. So the graph opens up, right? If it's greater than 0, then it's going to be one of these. And if it's one of these, then the vertex is the bottom. So let's say -5 is a maximum, or sorry, minimum value. That's what I want to say. -5 is a minimum value occurring at x equals -2. I think the last time the vertex where it's occurring. Now I think what I'm asking is it occurs at x equals -2. Okay, real life application. So you have some function which is going to tell you the height. That looks like y height. My highlighter is very slow loading. Okay, there we go. Y equals -16x squared plus 96x represents the height y in feet of a model rocket x seconds after its launch. So the x are the seconds ticking by. Y is how high it is at any given number of seconds. Okay, find the maximum height of the rocket find the maximum height of the rocket and when it occurred. Okay, so this is a little more difficult because when we look at the situation we have here, if we're finding the max and the min, we have 2 choices now. One is to look at this and go, oh, we're in standard form. We want the vertex, so we'll use axis of symmetry x equals -b over 2a. Totally could do that. You could substitute that value in for x and figure out what the max value is. But we're going to try completing the square. Do you remember what a has to be when you complete the square? It's got to be 1. So what we're going to do right now is we're going to rewrite this. But we're going to factor out a -16 because we need it to be 1. All right? So -16 times what is x squared? Well, that's just times x squared, right? Okay, negative 16 times what is 96? Now, I know you guys, like I do this stuff in my head all the time when I'm in class, but hopefully you know, say you're by yourself and you're like, oh, I just don't want to even think about it. I don't know. You guys, if you're factoring, then the inverse of factoring is division. So you can take 96 and divide it by 16, and you go, oh, it's 6 all along. It was not that hard. So this is 6. And of course, we want to make sure our signs work out. So negative times a what is this positive? A negative times a negative. Cool. We have x squared plus bx. Got the x. There we go. Okay, this is going to cause some problems. This negative 16 out here that we factored out is going to cause some problems. And it's going to cause some problems because if we try to complete the square here, we're going to have to deal with that negative 16 being there the whole time, which I don't mind. I'm going to just put a little flag here. Some students divide by negative 16 on both sides, and they just keep the negative 16 down here in the denominator. And then after we complete the square, they multiply both sides by negative 16. If you don't know what I'm talking about, just keep on watching. Okay, y. Y is going to be, oh, yeah. Okay, y equals, this negative 16 is chilling. Okay. Now, we're going to complete square. So I'll do x squared. I'm not going to do it the fast way like I did in blue before. I'll do it the red way just in case there's students who don't see it. X squared minus 6x. Okay, we're going to add a number and we're going to subtract a number so that we get a perfect square trinomial. But notice that negative 16 is still hanging outside these parentheses. It's still waiting. Okay, if I take negative 6, I divide it by 2, that's negative 3. Quantity negative 3 squared is 9. So I add 9 and I subtract 9. Have I changed the original x squared plus or minus 6x? No, because I'm adding 0. And then what does this become? And I don't know if I should do it in a different color, but we'll call it the inside parentheses. This inside parentheses should be a perfect square trinomial. Minus plus, it's a minus plus pattern. If this is a squared, then a would have just been x. If this is b squared, then b would have been just 3. And then 2 times x times negative 3 is negative 6x. Perfect. So that worked. And then there's the minus 9. And then there's the outer parentheses, which are still there. And the negative 16 is just hanging out, waiting for waiting to be multiplied back in. Okay, we're almost from standard form to vertex form, but this negative 16 now needs to multiply back in. So this becomes y equals negative 16 times the quantity x minus 3 squared, and then the negative 16 multiplies the negative 9 positive, and I think of this as 16 times 10 would be 160. But you only have 9 groups instead of 10. So that's 144, right? It's just 160 minus 16. There are a couple of things to check out here. First that I find interesting is, remember how I said A is the only thing in a quadratic that all of the forms, standard and vertex and intercept, they all have it in common. That A chases you around everywhere. The next thing to notice is, look again how easy it is to find that vertex. It's at positive 3 and then 144. Okay, let's think about what that means. Up here, height y, 144 feet. In x seconds, 3 seconds. So the rocket reached a maximum height of 144 feet. How do I know it's feet? Because it says it in the top problem. And when does it get there? After 3 seconds. All right, everybody, this takes practice. Keep on working at it. Ask any questions you have on Google Classroom. And remember, this isn't to understand right away. It takes many times. I would watch this video multiple times if I need to. Go online, cruise the internet, find other videos and other people to talk about it. You don't want to have to hear my voice the whole time. So keep it up, everybody.